Alright, ladies and gentlemen, in this video, I wish to prove to you something that you may never have thought about. I wish to prove to you that squares and square roots, apart from being new and confusing to some of us, there are also inverses. Mr. Grapp, it's been a while. What the heck's an inverse again? Okay. Inverses in math are things that are opposites that cancel each other out. So, for example, positives and negatives, they're inverses. They are opposites that cancel each other out, right? If I get a positive 1 and a negative 1, they cancel out and make 0. Another example of an inverse is multiplication and division. We use this all the time when we're trying to eliminate coefficients, because coefficients are multiplying. We divide by the coefficient, and that eliminates it. It's an inverse. They're inverses. They're opposites that cancel each other out. My proposal to you today that I'm going to prove is that squares, so like a squared, and square roots, they are also inverses. They are opposites of each other, and they will also cancel each other out. You may agree that they are opposites, but do you agree that they cancel each other out? Let's find out. Okay, so let's say I had the square root of 5 squared. The square root of 5 squared. If this is an inverse, I would expect this square and this square root to cancel each other out, and all I would have left is 5. Let's see if that's the case. What is the square root of 5 squared? Well, first off, let's take the square root of, let's simplify the inside of the radical. What's 5 squared? 5 squared is 5 times 5, so that would be the square root of 25. Let's keep that blue. And what's the square root of 25? Well, the square root of 25 is 5. Egad, Mr. Grapp, what a coincidence. You think it's a coincidence, but wait till the next one. Just to point out, the square root of 5 squared turned out to just be 5. So the square root of 2 squared, let's see what happens. Well, what's 2 squared? 2 times 2 is 4, so the square root of 4. What number times itself equals 4? 2. The square root of 2 squared is 2. Another coincidence. I don't know. First, it's a coincidence. Second time, I don't know. Third time, it's the enemy, right? So let's find out. What is the square root of 10 squared? Well, what's 10 squared? That's 100. So this becomes the square root of 100. And what's the square root of 100? By Jove, Mr. Grapp, it's 10. Hopefully you're seeing it. The square root of 5 squared was 5. The square root of 2 squared is 2. The square root of 10 squared is 10. Can you make a rule? Let's say I don't have a number. Let's say I have a letter. What would be the square root of a squared? Well, if it's the square root of a, well, let's see. 5 squared was 5. 2 squared was 2. 10 squared was 10. So the square root of a squared, if I just following this pattern here, would mean that the square root of a squared is just a. And that's exactly what it is. Because, as I'm trying to point out here, is that we've got a square root and we got a square. We got a plus and a minus. We got a positive and a negative. We've got a multiplication and a division. They are inverses. And so they end up canceling each other out. And when you cancel both of them out, what's left? Just the inside, just the a. Fantastic, right? But if these are truly inverses, it won't just work one way, it'll work both ways, right? A positive and a negative cancel each other out, and so does a negative and a positive. Either direction. So let's see if it works both ways. The square root of 81 squared. Okay, what's the square root of 81 squared? Well, the square root of 81 squared, let's move this over a little bit because I found out I have a little bit more room, so let's give myself a little more room. Well, 81, square root of anything. So something squared means itself times itself, right? So this would be the square root of 81 times the square root of 81. That's what it means when something is squared. It's squaring. It's multiplying by itself. And the square root of 81 is 9, so this becomes 9 times 9. And what's 9 times 9, my hard-rocking amigo? It's 81. Wait a minute. You're telling me the square root of 81 squared is 81? That's exactly what I'm telling you. Oh my gosh. That's crazy. What about the square root of 121 squared? Well, again, that would just be the square root of 121 times the square root of 121. And then I'll simplify. That'd be 11 times 11. What's 11 times 11? Muchacha lacha. That's right. It's also 121. The square root of 121 squared is 121. You lie. I'm not lying, my friend. But sometimes the truth is surprising. How about the square root of 36 squared? What would that be? Well, that would just be the square root of 36 times the square root of 36, which is equal to 6 times 6. No, say it ain't so. 6 times 6 is 36. The square root of 36 squared is 36. No! So what would be the rule then? Let's say I ditch all the numbers altogether and I want to make a rule using a letter. Well, the square root of a number squared would then just be, hold on, think, see for yourself. 81, 21, 21, 121, 36, 36. So the square root of a squared should be just plain old simple a. And that's for the exact same reason as the other example. Because once again, square roots and squares are inverses. So inverses cancel each other out. If they cancel them out, what's left over? Just the a. This might seem like a brain dead, yeah, Mr. Grab, I got it with the first example, but this is actually super, super important to understand for our next piece of this concept. We need to understand that if I have a square root, I can eliminate it by squaring it. And if I have a square and I wanted to get rid of that little 2 above my a, I can eliminate it by square rooting it. You'll see how important that is in the next video. So, catch you there.